Hello, everyone. Uh, Genetic algorithm for scheduling laboratory rooms is presented by Rafael Mayor, Martín Arrea, Mario Moncayo, Esteban Moya, Sebastián Trujillo, Juan Terneus, Robinson Guachi, Diego Pelufo y Lorena Guachi. To the outline, motivation, state of art, proposed method of genetic algorithm for scheduling laboratory rooms, a case study. This is our case study, preliminary results, and final remarks for future works. Motivation. The use of laboratory is of great importance for the training of more qualified professionals. Sometimes it represents a problem in some educational institutions. Laboratory capacity. Teachers' ability and cruising schedule for students or professors.
Okay, in the state of art, genetic algorithms are techniques based on various theories of biological evolution, in which only the strongest and best adapted individuals within an environment will be able to survive and reproduce. We can understand this as a competition generated from an initial population of individuals coexisting in a specific environment with limited resources, resulting in a selection of the best adapted individuals to the environment. Also, through mutation and recombination processes, these individuals become the progenitors of a new generation. These new individuals will now compete among themselves, resulting in an increase of population quality. In the state of art, we have defined it in three types, in three categories. The first one helps us to increase the research capacity for a near optimal solution, minimizing the cost of operation time overruns. Reinforcements learning algorithms reduce time consuming parameter setting task. And finally, with waiting time priority, genetic algorithms help us in the reduction of the total average time of all the activities of a schedule.
Okay, continuing with the state of the art, we chose three major groups. The first one is the fitness value, which evaluates how close a given solution is to the optimum solution of the desired problem. So basically, it determines how fit a solution is. The second one is the resource constraint, where there are limits on the availability of the resources. They offer good results by using sequential performance of multi-operator algorithms under two subpopulations. And finally, with the random factors, which is pretty self-explanatory, where a random solution is initially given. The data set that we chose for this case study was based on the information that we had back in the first semester of 2022. For this, we have the availability of 3 lab rooms. We also had 13 different times in which the lab was available for use. The number of teachers that required practices were 8, and in between them, there were 17 different subjects, such as electronics, mechanics, and more. Finally, we had a different capacity for each lab room. So for the first one, we had 25 spaces. For the second one, there were 10 spaces. And in the third one, there were 15 spaces.
So the first step in the flow chart, it's the initialization of the population. So the first generation is randomly generating using certain parameters, such as the subjects that belong to each academic level and which teachers can teach that subject. Then we have the fitness of the population that is calculated considering the number of conflicts found in each generated schedule. Then we have the selection. The individuals with the best fitness value will be chosen for the creation of the next generation. And it allows to the algorithm to get closer to the optimal solution. In this case, the optimal schedule. And in this application, the individuals are selected by a tournament technique in order to obtain the fittest individuals. These selected individuals are chosen by a set percentage or number at the beginning of the algorithm. This value also can be changed to admit more or less individuals as parents for the next generation. Then we have the crossover. The crossover operator uses the parents selected from the previous generations to make a new one by mixing the genetic information of the fittest, generating populations with better fitness parameters, and the information taken from the parents can be defined by many techniques and parameters. In this work, we use a random number to determine how much genetic information will be taken from each parent involved. And then we mix it randomly with different characteristics. And we create completely new individuals for the next generation. And finally, we have the mutation. It consists of taking the new generation that has been created and altering its genetic information or characteristics with different techniques. So we apply a mutation rate that is established at the beginning of the algorithm, and which will determine the probability that an individual is mutated. This value was chosen to ensure the variety of individuals while maintaining their quality. So if a randomly generated number turns out to be lower than the mutation rate, the schedule or individual is mutated or generated again. So finally, the mutation is used to maintain the diversity among individuals in a population, avoiding problems such as the genetic algorithm not converging quickly enough.
Okay. So in order to improve the algorithm, we modified an operator, which is the mutation operator. In this case, we chose to generate a random number, which inside the mutation operator, inside a for loop, it's going to do certain things to the population. So if the random number generated is under 0.05, one of the first 10 courses of the schedule is chosen to be replaced with a new generated course. Otherwise, if the number is higher than 0.05 but lower than 0.1, one of the courses between 13 and 17 is chosen to be replaced with a new generated course. This is done to give some variety to the next population and helping the algorithm to converge faster. Also, we have the experimental setup. For the development of the algorithm, we used Google Colab, which has some specifications of 100 gigabytes SSD disk with 2 gigabytes of RAM. The metrics we evaluated were the convergence time in seconds, highlights how fast the algorithm converges. Also, the result effectiveness, which evaluates the fitness of the individuals of the last generation. And finally, the constraint compliance, which is the number of conflicts presented by the last generation of individual. Here we can see also the parameters we used, the population size. It's the parameterized, the number of individuals within the population. We chose an initial value of 9. And this value was selected experimentally. We determined that this was the optimal value for the population size. Also, we have the selection pressure. This is a parameter that allows to set how many individuals, or in this case, schedules, are going to be selected to be parents for the next generations. We selected a value of 1. And this selection was because in the investigation we did, we found that the parameters, these were the parameters specified in the Bayes algorithm. Also, we have the mutation rate, which is a parameter that compared with a random number, which determines if a mutation is done or not. So equally, this value was determined experimentally. And we chose a value of 0.1 and 0.05.
Okay, so as the main result, we obtained that the proposed genetic algorithm achieves the highest average value of 0.327 against our 0.278 reached by the Bayes algorithm. Here we can see our results, that is the GA controlled by a mutation and the GA with single random mutation. Achieving those average values in this convergence time results of effectiveness and constraint compliance, which are what we are going to see in our next graphics. Here we can see the convergence time, which shows us that the genetic algorithm with single random mutation has a higher value. Then in the result effectiveness, we can see that in some number of executions, the genetic algorithm with controlled mutation has a higher value, and in other executions, the genetic algorithm with single random mutation has the higher value. So now, for the constraint compliance metric, the number of conflicts found in the schedule or individuals is taken into account. For this reason, as shown in this figure, the higher value, the worse the result. So in the proposed genetic algorithm, there is a minimum value of 1, that is our number of conflicts, and a maximum value of 4. On the other hand, we have the Bayes algorithm with a minimum value of 1 and a maximum value of 5. So as the conclusions, we obtained that after comparing the Bayes algorithm with the one that was implemented, there is a visible improvement in all the metrics. One of these metrics, the 41% in the convergence time, 36.36% in the results efficiency, and the 25% in the restrictions compliance. So, but also we obtain a disadvantage, that is that if the data set wants to be enhanced, all the parameters must be changed and reconsidered. For a future work, we take into account that an improvement can be make a user interface and incorporate it so that the user can input the information according to its necessities without reconsidering again the parameters. And here's all the presentation of our work, genetic algorithm for scheduling laboratory rooms. Thank you very much.